All right, so step one of today's lesson is just making sure you have this written down to your notes. It should be old and familiar kind of stuff, but it still is nice to have it handy, to have it actually written down in front of you so you can look back at it. Because you know, of course, we're going to be using this, and because it is basically considered a review, I am going to push you a little bit to some of the tougher types of problems that you might have seen, depending on where you're at with it before. All right, now we're going to start our logarithm practice and review here with these two problems. Go ahead and write down that first one, log base 2 of 16. And as you do so, I do want to point out that these actually don't even require using those rules you just wrote down. In fact, this goes back to the definition of a logarithm. Now, because these are nice early practice problems, you won't even need a calculator for these. So, the first one, log base 2 of 16. We can know what that is off the top of our head if we remember how to read the logarithm, right? What does log base 2 of 16 actually equal? Yes. 4, absolutely. It equals 4. Now, how would we know that? Because if you're looking up here saying, that's magic. Let's just clarify where this comes from. Basically, when we see a logarithm, I can read this as 2 to the power of what equals 16. Because logarithms are used to solve for an exponent. They tell you exponent values. And so the answer to it is the exponent. So 2 to the power of 4 is 16. That's how we'd get that. Go ahead and take a look at the second one then. Log base 4 of 1/16. All right, and once again, you shouldn't need your calculator for this one. So what is the answer? Log base 4 of 1/16 is? -2, absolutely. So it ends up giving us -2. Now this one sometimes can be a little bit trickier, but the fraction is what's telling me to include the negative. Now again, it's looking like this. 4 to the power of what equals 1/16. Remember that a negative exponent flips a number into the bottom of it. So by making this a negative up here, that's telling me this goes down here. And then 4 to what power is 16? 2. So that's why it ends up being the -2 in particular along there. All right, next one. This one will require those rules that you've written down. And for this one, you again won't need a calculator because it says simplify, not evaluate. In fact, you're not going to need a calculator for the vast majority of these. I think there might only be one where you'll even make use of it. But use those rules you wrote down at the start of class and simplify this. As you're looking at this, if you're not sure where to start, think order of operations. Because there's two different things we can do using the rules. We can do the subtraction, but there's also this multiplying by 2. Order of operations says deal with the multiplying by 2 first. All right, so let's go ahead and go through this then. So this 2 goes in as an exponent, which means this becomes log base 3 of 7 squared. Because whatever's inside the logarithm, it ends up taking that power of 2. Now I'm going to go ahead and then take this 2 and make it log base 3 of 7 squared becomes 49. Now remember, that's just working that down. I haven't touched this log base 3 of 5. It's still just hanging out here all the way down. But now that I dealt with the 2 that was multiplied, I can now deal with the subtraction, and subtraction tells me to turn it into a single logarithm where I do what with the 5 and the 49? Divide. Yep, the subtraction tells me to go to division. The first number always goes on top, the second number always goes on bottom. And so we got log base 3 of 5/49, and that is our final answer. Again, I'm not taking it any further like with the calculator because it says simplify here. It does not say evaluate. All right, now we're going to get into solving. So, time to solve these two. And yes, on both of these, you should be able to do both without using your calculator. All right, so let's go ahead and take a look at this first one here. We have log of something equals log of something. Both sides are log of something, and that's all there is over there. Because of that, those two somethings must be equal to each other. Because we're taking log of both of them, and they're still going to be equal to each other. So 2x plus 3 must equal 53. Now that is a lot simpler of an equation to work with, right? So we solve it like we normally would. We subtract 3 from both sides, which gives us 2x equals 50. I divide both sides by 2, x equals 25. Final answer done. On the second one, if you have been feeling a little bit stumped about how to approach it, step 1, use those log rules you wrote down at the start of class and combine that into a single logarithm. Alright, so just like we saw in that previous one where we were simplifying, the subtraction is going to lead us into division. So this is going to be log base 5 of 18 divided by 9. And 18 divided by 9 is 2. And then I haven't done anything with the right side, so it's still log base 5 of x. Now once again, notice what we have here. I have log base 5 of something equals log base 5 of something, and that's all that we have on both sides. Therefore, those two somethings, they must be equal to each other because we're doing the exact same thing to them. And look at that, we got a final answer. 2 equals x. Love it when it works out nicely. Let's see if these two work out as nicely. And once again, you won't even need your calculator on. All right, and once again, the first thing I want to do on this one on the left here is to turn it into a single logarithm. Now in that case, we have addition between the two logarithms. So when I turn it into just a single logarithm, what do I do with the stuff inside? Addition leads to multiplication. Yep. So that tells me that I'm going to do log of x times the x minus 9. Notice I got to distribute the x to both of them then. So the x times x gives me x squared, and the x times the 9 gives me 9x. And that's going to equal 1. Now in the previous couple problems when we were solving these, I had log of something equals log of something, and so I was able to just strip away the logs. I cannot do that in this case because there's only one logarithm. But what I can do, since I have just one logarithm, is I can take it and change it from logarithm form into exponential form, which is really the foundation of logarithms. So this is definitely a good skill. Make sure you have it down. Before I do that, I need to remember, what is the base of this logarithm when I don't write it in? 10. Absolutely. So that means that when I write it as an exponential, it's going to be 10 to the power of 1 equals whatever was inside the logarithm. So in this case, that means it equals x squared minus 9x. And of course, 10 to the 1 is just 10. So we got 10 equals x squared minus 9x. How do I solve that? Notice it's using some different skills along the way. We got a quadratic. In order to solve this quadratic, we first set the whole equation equal to 0. And then once you do that, can this one be factored? I hope so, because if it can't be factored, what do we have to use? Quadratic formula. Yeah, everybody remembers quadratic formula? If not, you'll have to be looking it up on tonight's assignment because it's going to come up. All right, but before we get there, yes, this one is factorable, so let's go ahead and factor it here. It ends up being x minus 10 times x plus 1. And so we get x equals 10 and negative 1. Can anybody spot a problem with that answer, though? Yeah, we cannot take the logarithm of 0 or a negative. Whatever is inside the logarithm, whatever taking logarithm of, it has to be a positive number. Now, if I plug 10 in for x here, it works. Both of those will give me positive numbers. However, if I plug the negative 1 in, it gives me negatives. Therefore, the negative 1 is extraneous. It is an extraneous solution, therefore not really a solution, so we only have that x equals 10. Right now, for the second problem, there are a couple different ways you could approach it. I'm going to start by going through it using the method that works for any and every problem that might be set up like this, regardless of which numbers they are. And that is, since I just have an exponential, I'm going to go ahead and turn that exponential into a logarithm. And so if I change this into log form, it's going to be log base 8 of 64 equals 6x plus 1. Now the log base 8 of 64, we can actually know what that equals. 8 to the power of what is 64? 2. So I end up with 2 equals 6x plus 1. And then we can solve that from there. So I subtract 1 from both sides, I divide both sides by 6, and I end up with x equaling 1/6. Great. Now that method would work regardless of which numbers they were. But in this particular case, the numbers actually are kind of pretty numbers for being able to do this another way. Because on the left side it's 8 to the power of, and when I look over at that 64, I recognize, hey, that's also 8 to the power of something. I could just write that as 8 to the power of 2. And if I do that, then since both sides are 8 to the power of something, those two somethings must be equal to each other. And so 6x plus 1 equals 2. And you'll notice we get the exact same thing whichever method we used it. So you just continue solving from there. Whichever way you use to get to that point is fine. Just remember that the second method works because we can see that. We recognize that we have that pattern in there. The first method would work even if we didn't have nice pretty numbers to be able to do it with. Alright, next up, these last two that we're going to solve here together, you will actually need a calculator for one of them. Just one of them. So for first problem here, the left one, the first thing I want to do is I want to take this -5 and I want to move it to the left side just to make our lives a little bit easier. So that's going to be 5 to the 2x plus 1, because I didn't change or touch that part, equals, and then I add the 5 to the 18, so that gives me 23. All right, now that I have the exponential, I'm going to have to turn it into log form. There's no way to use a nice, neat little trick like we did on that last one. And so this becomes log base 5 of 23 equals 2x plus 1. And now we have to break out the calculator to figure out what is log base 5 of 23. So in order to calculate that, we got to use the change of base formula. So change of base formula, that's where we do log divided by log. More particularly, remember, 23 in this case goes on top, 5 goes on the bottom, because the base will always go on the bottom. Side note, if you wrote it as natural log of 23 over natural log of 5, that would also be perfectly fine. Both work. All right, and then this is still going to equal 2x plus 1. So we go ahead and do that calculation to figure out what log base 5 of 23 is, and it's about 1.95. And that gives us 2x plus 1, so then we solve it from there. So we subtract 1 from both sides, then we divide both sides by 2, and you should get that it's about 0.47 for x. Then we move on to number 2, where the first thing I want to do is get the log by itself, so I add 4 to both sides. So now that I made it simpler, I look and see what I've got here, and I have a logarithm by itself. Since I have a logarithm by itself, that tells me to turn it into exponential form. So that means it becomes 2 to the power of 5 equals x minus 3. And then 2 to the 5th, that's 32. And then we add the 3 to both sides, so we end up with a final answer here of x being 35.